Good morning, everybody. How are you all? Today we are going to talk about limitations of least square regression line. So here I go. Features and limitations of least square regression line. So we are going to understand the importance of avoiding extrapolation, compute residuals and state the least square property, construct and interpret residual plots, determine whether outliers are influential, compute and interpret the coefficient of determination. Understand the importance of avoiding extrapolation. Making predictions for values of the explanatory variables that are outside the range of the data is called extrapolation. So, for example, here, if you look at the horizontal axis, size square feet, it ends at around 32, 3,200 feet. Now, we can make up, and the maximum value is 3,200 square feet on the horizontal axis, corresponding to one of the ordered pairs on the top. And the minimum X values is around 2,500 square feet, which is the lowest point on the clustered around the line. So suppose I want to make a prediction for explanatory variable or X value of 3,400 square feet. Now that is outside the range of the explanatory variable, which runs from 2,500 to 3,300 or 3,200. So 3,400 of X value is outside the range of the given X values. And in general, it is the best practice not to use the least square regression line to make predictions for X values, that is, predict Y for X values that are outside the range of the data, because the linear relationship may not hold there. As you can see on the top, we do not know how the line will keep going up, or maybe it will level up. We don't know. So definitely we should not try to predict or forecast Y for a value of X which is outside the range of the given X values. Check your understanding. A sample of adults was studied to determine the relationship between educational level and annual income. The least square regression line for predicting income from education level was computed to be y hat equal to 2,812 plus 3,375 times x, where x is the number of years of education. The number of years of education among the people in the sample from which the data was collected ranged from 8 to 18 number of years of education. Decide if the model should be used to predict income for each of the following. Remember, y hat is the predicted income, x is the number of years of education. And the data that has been gathered, data set that has been gathered, X values varies from 8 to 18. So can we use this linear regression, least square regression line to predict the values of Y for the given values of X, such as X, a person with 12 years of education, that is in between 8 to 18. So we can use the least square regression line for X equal to 12, plug it in the least square regression line equation to predict Y. A person with 6 years of education. Remember, X value in the actual data set varies from 8 to 18. 6 is outside the range, so do not use the least square regression line. The third one on the bottom left, a person with 20 years of education, again, X is outside the range from 8 to 18. Therefore, do not use the least square regression line to predict the value of Y for X equal to 20. A person with 15 years of education, yes, you can use the least square regression line since X values fall between X value of 15 falls between 8 and 18. Compute residuals and state the least square property. Given the point x, y on the scatter plot, the least square regression line y hat equal to b0 plus b1 x, the residual of the point is xy, is the difference between the observed value of y and the predicted value of y. So what exactly it is? It is the vertical distance of the actual point from the fitted line. So for points which are above the line, the vertical distance of the point from the fitted line will be positive. And for points which are below the fitted line, the vertical distance from the point to the fitted line will be negative. For the least square regression line for predicting the selling price of house size from house size was y hat, that is the selling price, is equal to 160.1939 plus 0.0992x. We may compute the residual for the point to x is 2555 and 426. So we take the x value of 420, sorry, x value of x value of 2555 and plug it in the equation. Okay. And the y hat value is actually not 143.6, it is 413.6. Notice the predicted y hat value of 413.6. That is definitely wrong, not 143.6. It is 413.6, is slightly below the actual point, data point y value of 426. So the vertical distance of the actual point, 2555, 426, where x value is 2555 and y value is 426, is the actual data point. So the vertical distance of that actual data point from the fitted line is 426 minus 413.6 is positive 12.4. That difference is called the residual. Okay. The magnitude of the residual is just the vertical distance from the point to the least square line. The least square line is a line for which the sum of the squared vertical distance is as small as possible. It follows that if we square each residual and add up the square, the sum is less for the least square regression line than for any other line. This is known as the least square property. So we already noticed for points which are above the actual points which are above the fitted line, the vertical distance of the point from the fitted line is positive. And for points which are actually below the fitted line, the vertical distance of the point from the fitted line is negative. But if you square a negative number, it's positive. If you square a positive number, it's positive. So for the least square regression line, the sum of the squares of the residuals is minimum. That's why it is called least square, lowest value of the square of the deviations of the line from the deviations of the points from the fitted line. Okay. Least square, square of the vertical distance of the point from the lines, or sum of the squares of the points from the fitted line is kept to a minimum in the least square regression line. This is the least square regression property. Construct and interpret residual plot. Remember, residual plot is the y actual minus y predicted. The actual value of y or observed value of y minus the predicted value of y from the least square regression line. That is the definition of residual, the vertical distance of the point from the fitted line. A residual plot is a plot in which the residuals are plotted against the values of the explanatory variable x. When two variables have a linear relationship, the residual plot will not exhibit any noticeable pattern. If the residual plot does exhibit a pattern, such as a curved pattern, then the variables do not have a linear relationship and the least square regression line should not be used. So again, what is a residual plot? It is residual on the y-axis versus the explanatory variable x on the horizontal axis. We do not want to see a pattern in the residual plot. If we see a pattern, then the linear relationship is not a good fit, and least square regression line equation should not be used. Do not rely on the correlation coefficient to determine whether two variables have a uh, linear relationship. Even when the correlation coefficient, that means the R value, is close to 1 or minus 1, the relationship may not be linear. To determine whether two variables have a linear relationship, construct a scatter plot or a residual plot. Okay. Remember, X is the size in square feet, selling price is Y, selling price is in hundreds of thousands of dollars. That is the selling price of a house, 2,521 square feet. It's actually 400,000 square feet, but we have removed the last three zeros by dividing each selling price by 1,000. Okay, so let's enter the X value in L1 of the calculator and Y value in the L2 of the calculator. So the first thing we do is put the calculator on, press the second button, then the plus button on top of enter, then number 4, which gives clear all list, hit enter, done. Then stat button 1. In L1, we are going to enter X values, which are the square feet of the houses. So 2521, 2555, then 2735, then 2846, then 3028, then 3049, then 3198, and then again 3198. So we have entered the last data point in L1, X value. Then we will move the cursor to the first line in L2 by pressing the right cursor key, which is in the top right corner of the calculator. So press the right cursor key to move the cursor from the bottom of L1 to the first line in L2. When you do that, you're ready to enter the Y value there. So 400, 426, 428, 435, 469, then 475, then 488, and 455. Okay. Now we will calculate the residual. What is the residual? It is the value between the actual Y value, Y actual or Y observed value, which are the selling price in L2, minus the Y predicted for the given X values using the least square regression line. So we first move the cursor to the first line in L3 by pressing the right cursor key. So we are on the first line in L3 now. Cursor is sitting there. With the up cursor key, we'll move the cursor. With the up cursor key, move the cursor, a black rectangle, to where L3 is written. Okay. And then press second button on the top left corner and stat. Okay. And scroll down in the first screen to RESID, RESID. So you're on top of L3, second button, stat, which is in the second row of the calculator. You scroll down to 8, which is RESID, and hit enter. Look at the bottom of your calculator, left bottom. You have L3 equal to RESID. What does it mean? It means L3 will be filled with residual value, which is Y actual minus Y predicted. And hit enter. No, we didn't get anything. So first we have to do the regression. So let's do the regression between L1 and L2. So stat, calc, number 4, X list is L1, Y list is L2, and we calculate. This way the calculator will calculate the least square regression line equation between X and Y, which is Y equal to 0.0992X plus 160.19. Now that it has already gotten the least square regression line, if we go to the next step, what it will do is take each given value of X, plug it in the least square regression line, and get a value of Y hat, which is the predicted Y hat. Then the residual is the difference between the actual Y or observed Y minus the predicted Y. So now we press the stat button, then 1, move the cursor to the first line in L3, then up cursor key to move it to where L3 is written, then second button on the top left, and then stat, which is in the second row. And then scroll down to number 8 position in the first screen, which is RESID, RESID, and hit enter. And now again hit enter. Now L3 is filled with residual. So we want to make a plot of residual on the y-axis and the x value. Remember, residual is in L3, which will be y, and x value is already in L1. So what do? We press the second button and y equal to, okay? Press number 1. First line flashing on. Second line, put the type on the first type of chart, which is a scatter plot. Now our X list is X value, which is an L1. Our Y list is not L2 because remember in L2 we have the selling price, whereas we have the residual in L3. So go down, bring the cursor to the right of Y list, and instead of L2, we are going to plug in L3 over there, which is second and 3. So right now we have X list as L1, Y list as L3, type is the first type of chart. Then press zoom, which is the third key in the extreme top row of keys, zoom and 9. And you will see the same residual plot that you see on the screen over here on the PowerPoint. What do you notice? As X increases, there is no particular pattern. Okay. The residual plot exhibits no noticeable pattern, so use of least square regression line is appropriate. So again, residual plot is the residual value versus the X value, and we don't want to see any particular pattern there. Okay, for each of the following residual plots, determine whether a linear model is appropriate. It's okay for the first one on the left. In the residual plot, always the horizontal line is at y equal to 0. So you want to see some points above the horizontal line y equal to 0 and some points below it. You don't want to see any pattern. Okay. But on the one on the right, although the points are located above and below the y equal to 0 horizontal line, but there is a particular pattern. Okay. Cyclical pattern, a cycle is there going up and down and again up. We don't want this kind of pattern. So the least square linear model is appropriate for the diagram on the left. And it show you how to make the residual plot using the calculator. Determine whether outliers are influential. An influential point is a point that when included in a scatter plot strongly affects the position of the least square regression line. Consider a scatter plot of farmland versus total land area for the United States. Okay. The solid line on the plot is the least square regression line computed for 48 states, not including Texas or Alaska. Texas is given by the red point and Alaska is on the bottom right, extreme right, but it has got a large land area, but very little of it is farmable. So its Y value is really low. For Texas, the X value is in the middle, the Y value is very high. So forget Texas and Arkansas, these are influential plot. And if you take the remaining 48 points, 48 states between total land area and which is X and Y farmable land area, you will get a straight line going up the hill, the blue solid line. Okay. Now, if you include Texas, what do you see? The dotted line is the least square regression, the red dotted line, least square regression line for 49 states, including Texas. That what does it do? By including Texas, we increase the slope or the stiffness of the line going up the hill. However, what happens if we include also Alaska, the dashed dot line, which is the lowest slope line? Okay, the dashed dot line is the least square regression line for 49 states, including Alaska. Including Alaska causes a big shift in the position of the line. In other words, the slope becomes much shallower because Alaska is a large land area, but very little of it is farmable. If you include that value of Alaska, that XY value of Alaska, it will pull the slope down. What is the message from here? So do the regression without including the most influential points, and later on you might include the influential points and see how it shifts the slope. Issues with the influential points are troublesome because the least square regression line is supposed to summarize all the data rather than reflect the position of a single point. When a scatter plot contains outliers, the least square regression line should be computed both with and without each outlier to determine which outliers are influential. If there is an influential point, the best practice is to compute the least square regression line both with and without the point, and the equations of both lines should be reported. Now we are in a position to calculate the coefficient of determination. Okay. So look at the point xy on the top right, xy. It has a x coordinate of x or y coordinate of y, ordered pair xy. Okay. Look at the horizontal line. So the fitted line goes up the hill. There is a horizontal line at x bar or at y bar. This is the average value of all the y's. So we draw a horizontal line at y bar. Now we take the actual location of the point xy. What is the difference of that line from the average? We divide it into two parts. The top part is the difference of xy from the fitted line. Okay, that difference, the top difference, which is smaller here, is the unexplained difference. Okay, and then the second part, which is the difference from the fitted line to the y average value, is the explained difference. Why it is explained? Because this part depends on the average of all the y's and the particular position of the line xy, xy bar, okay, xy hat, okay. So again, let me go over it. Xy is the point located on the top, above the fitted line, clustered above the fitted line. We take the difference of y value for that point from the average value y bar, which is a horizontal line. We divide that difference y minus y bar, or the difference of y from the average value, into two parts. The top part, which is the difference from y to the predicted value of y on the fitted line, y minus y bar, okay, is the unexplained part. Whereas the explained part is the bottom vertical portion, which is the difference from the fitted line y value, which is y hat minus y bar. So the first part, y bar minus y bar, is the difference between the central value of y bar and the predicted value is the explained. So as I said, the difference from the fit of y value from the fitted line to the average value, which is y bar, y hat is coming from the fitted line, minus y bar, which is the average value of y, which in this case is the bottom difference, is the explained difference. And the difference represents the difference explained by the least square line. So the difference, the portion of the difference of the fitted line xy, which can be explained by the least square regression line, is the difference, vertical difference from the y hat, which is on the fitted line, minus the y bar, which is the horizontal line average value of y. Okay, this is the explained part because this can be explained by the position of the fitted least square regression line. And the top part, which is y minus y hat, top part, y minus y pair, the y hat, y minus y hat, y is in top, y hat in the fitted line, is unexplained, is the difference between the observed value and the predicted value y hat, which is just the residual. Okay. So y minus y is the observed value, actual value of y, minus the y hat, which is the value of y or the same value of x on the fitted line. Okay, it's just the residual actual minus the predicted, actual value of y minus the predicted. Okay, and it is called unexplained difference. This difference is caused by factors unrelated to least square regression line. It is called the unexplained difference. Okay, the better the least square predictions are, the smaller the unexplained difference will be. We measure the size of the explained unexplained differences by squaring them and adding them together. This quantity is called unexplained variation. The explained variation is found similarly with the explained differences. Okay, you square the difference to get the square of the actual point from the fitted line, square of that vertical distance, y minus y hat. You square it, that is the unexplained variation. The square part is called the unexplained variation of that vertical distance. Similarly, the explained variation is y hat from the fitted line to the y average. Okay, that difference is squared. That is the explained variation. Okay, when two variables have a linear relationship, the correlation coefficient tells us how strong the relationship is. The measure most often used to measure how well the least square regression line fits the data is r square. The closer the value of r square is to 1, the closer the predictions made by the least square regression line are to the actual values on average. The quantity r square is called coefficient of determination. It can be shown by advanced method that r square is equal to explained variation divided by unexplained variation plus the explained variation. So explained variation, remember, is the vertical distance from the fitted line to the average value. You square that, that is the explained variation. So that remains on the top of this r square definition divided by sum of the squares. One is the explained variation, which is the distance from the fitted line, vertical distance to the average. That is the explained variation. The unexplained variation is the actual vertical distance of the point y minus the predicted y minus the predicted value of y on the fitted line. So sum of the squares of the variation are in the denominator, and on the top you have the explained variation, which is the vertical distance from the fitted line to the average value of y. Okay. So r square then is the percentage of the variation in y that can be explained by the least square regression line. Thus, r square measures the proportion of total variation that is explained by the regression line. So it is explained variation, square of the vertical distance of the y hat, fitted value of y, minus the y average. Explained variation divided by sum of the squares of the two variation or the total variation. That means r square, when converted to percentage, tells you what percentage of the variation in y can be explained by the least square regression line. So here is the data we have. Okay, so we do stat, calc for least square regression line L1, L2, and we calculate and we get a R square value of 0.811. What does it mean? 81.1% of the variation in Y, which is the selling price, is explained by the least square regression line. Okay. For each of the following values of the correlation coefficient, determine how much of the variation in the outcome variable is explained by the least square regression line. R is 0.6, R square is 0.6, 36% of the variation in Y can be explained by the least square regression line. Second one on the top, R is minus 0.9. If you square minus 0.9, minus 0.9 times minus 0.9, two minuses make it plus. R square is 0.81, or 81% of the variation in Y can be explained by the least square regression line. R square is 0, no problem. Nothing can be explained. R square is 1, or 100% of the variation in Y can be explained by least square regression line. Okay, so this is, so remember, residual is the actual value of y minus the predicted value of y. We get the predicted value of y by taking each x value and plugging it in the least square regression line equation. The y minus y hat, or the actual y minus the predicted y, is the actual residual. It is the vertical distance on the top as shown in the figure. Okay. Unexplained variation. Least square property, sum of the squares of the residual is kept to a minimum. How to construct and use a residual plot. We do not want to see a pattern in the residual plot versus the x values. What an inflation plot is and how they can affect least square regression lines, and how to compute and interpret coefficient of determination, which is R squared. So I'll stop here today. If you have any question, comment, please write me a note. I will answer to your comment. If you like my video, give me a thumbs up. I appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button and let YouTube know that you would like to be notified every time I upload a new video, which I do almost every day. And please do not forget to watch me tomorrow when I'll be back with another interesting presentation. Thanks for watching. Take care. Have a nice day. If you want me to solve any particular problem, let me know. Send me a comment. I will do that. Okay. Thank you very much. Take care. Have a nice day.